All right, folks. I don't want to bore you, so I think for the first, I don't know, I don't want to, I don't want to be up here for more than like 15 minutes. Now, this might be some stuff you've seen before, or maybe it's completely brand new to you. But nonetheless, here we go. Does everyone have something to write with? Yes. Got a calculator. You might not need one, but you should have one in front of you. But yeah, pencil, calculator, and this note. And here we go, folks. Actually, let me. Alrighty. Exponent laws, part one. Yeah? Now, I got one question for you folks. Yeah, yeah. So folks, in math, what's a power? I know it's kind of a weird question. We've dealt with powers before, especially with BEDMAS. Yeah, yeah, kind of very similar to that. A power is a mathematical, oh, no, we're going real nerdy terminology here, but you're totally right. Is a mathematical expression that represents repeated multiplication, or what Riley said. Riley said something like, I would write it, yeah, for sure. You can, yeah. Sure. Yeah. That's actually a pretty good habit to get into. I know sometimes we might write everything down on our page because it's on the teacher's board, right? We should have that written down. But really, I think it's a good idea to get into the habit of kind of summarizing what the teacher has on the board and then writing that in your notes because one, it's in your own words, and two, helps you like kind of digest the information a little bit better. So we have something like this. There's parts of a power, and you've seen this before. We've talked about this many times. We have, well, this number 2 here. This number 2 is what we call the base. So be sure to write in base right there with that arrow. It's the base number. And then this little number up here is called, well, I know you know this, it's the exponent. And we call this whole thing here a power. Yeah? And a lot of the times we say 2 to the power of 5, but really what we should be saying is 2 to the exponent 5. Yeah? Because the whole thing, 2 to the exponent 5, is called a power. Okay. Here's some examples. So 3 to the exponent, or really to the power of, I don't know, to the power of 4. Now, you could go right into your calculator there, but because we know that a power is just repeated multiplication, really what this is 3 times 3 times 3 times 3, multiplying 3 by itself 4 times. Or we're taking that base number, 3, and multiplying by itself 4 times, the exponent 4. And then now there's some sweet mental math tricks to this. 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. Or you can just go to your calculator, 3 exponent 4, life is good, 81, okay. Now part B here, 4 to the exponent 3, and I know you know this, we're going to take that base 4 and multiply it by itself 3 times, 4 times 4 times 4, and really what we call this part of it, when we're multiplying the base by itself a bunch of times, we call that a product. Did you get it? You're close. You're so close. Your 3 by 3 algorithms are going to work now. Okay, and then 4 times 4, 16 times 4. Anyone? That's a tough one to do mental math. 64? Is that what you said? Yeah, 64. Nice. Good mental math. But always confirm with a calculator, of course. Okay. Now, boys and girls, exponent laws where we're like, they are, I gotta let you know, they are the biggest shortcut you'll ever see. In fact, what I've done is I've compiled every exponent law we're going to learn in this course, and I put this in a little handbook for us to have. Yeah. So it is great. And I'm going to give it to you maybe when we go to the boards today. But exponent laws are essentially a giant shortcut for us. And in order to appreciate these giant shortcuts, or really to appreciate these exponent laws, we kind of got to see it the long way, and we'll be like, oh, okay, I see what's going on here. So here's a great example. Here's the big idea, and we should write this down. If we have 3 to the exponent 5 multiplied by 3 to the exponent 4. Now, I think so far, if we were to kind of do this by hand, the best thing to do here would be to kind of expand the things you see in the brackets, right? So 3 to the exponent 5 we know is 3 times 3 times 3 times 3 times 3. And 3 to the exponent 4 is 3 times 3 times 3 times 3. I know, and I need you to write it down. I know. Question? Yes, yes, you can. We're going to get there. Okay. but Adam, yes, I know where you're going, but this is why we can, okay? So, 5 threes, of course, multiplied by 4 threes. Okay, great. Now, because we're multiplying everything, we're allowed to just drop the brackets. So what we're going to have is 3 times 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 3. Yeah, I would certainly write this down. Absolutely. Now, that is going to be quite a large number. But if we were to write this, all these threes, as a single power, meaning like 3 to the exponent what? Quinn? 3 to the exponent 9. Yes. Now, Adam had his hand up for a little while there, and I didn't call on him on purpose because I think he knows what happened. Adam, if we were to do a giant shortcut here, if we started at the question, 3 to the exponent 5 times 3 to the exponent 4, and we wanted to just go right to the final answer here, 3 to the exponent 9, what can we do? What is happening mathematically? Yeah, we're just going to add the exponents, and we're allowed to do that because these powers have the same base number 3. So here is the law, the exponent law. And the exponent law is if you have some base x to the exponent a, and you're multiplying that by some base x to the exponent b, notice how they have the same base x? What we're able to do is we're able to add the exponents together, just like that. So far, so good? Okay, great. Well, let's do maybe a few examples. So how about this one? 5 to the exponent 3 times 5 to the exponent 7. Maybe you should take up, did I write that down for you? Or maybe you got to write that down. So go ahead and write that down real fast. What would be our answer here, Riley? Yeah, that's right. 5 to the exponent 10. Absolutely. How about this one? Negative 2. Now, whoa. Be careful with this one. This one's a little bit tricky. We have 2 to the exponent 4 times, negative 2 to the exponent 4 times negative 2 to the exponent 3 times negative 2. Nathan, what do you got? To the exponent 8. Yeah, think about that. He's absolutely right. Negative 2 to the exponent 8. Now, hold on. How come this is the right answer? Because, yeah, Quinn. Yes. Those who didn't hear that, Quinn said, okay, yes, we have the 4 here, we have the 3 here, and then the exponents 4 and 3. And this last one, this negative 2, without an exponent, we should know that there is an imaginary exponent 1 there. Yeah? So maybe what I'm going to do with my pen, at least I'm going to try to do here, I don't know what's going to happen. It's always a surprise with this thing. And there's a little exponent 1 there, and I know it's not there, it's not ever there. It's very similar to like the coefficient of x. We have y equals x plus 5. We know that it's 1x, right? Same thing with exponents. If it's not there, you know there's an exponent 1 there. And what you did was just add the exponents. That adds to 8. Lovely. Folks, this is the multiplication law. Does anyone have any questions about it? Okay, before I fall asleep. This last one here. X to the exponent 16 times. Now notice how there's no symbol here. There's nothing. Sorry, I know it's kind of low there. But we have to remember that there's nothing there. It really just means multiply. Sometimes you might see a little dot, like a little dot like that. That also means multiply. So x to the 16 times x to the 5. Who's got an answer? Cameron? X to the exponent 21. Lovely. Now you're probably wondering, why aren't we going ahead and stating the answer as like an answer, like a big number? Well, because sometimes exponent laws just, it's way easier. Sometimes those big numbers are a little bit unreasonable to write down, so it's a little bit better to just leave it like that. Cool? Okay. Now, law number 2, we call it the division law, and here's the big idea. And again, I'm going to need you to play along up here, and yes, we're going to be writing down quite a bit of numbers, but it's only the one time we're going to do it so that we can appreciate these laws. So we have here 4 to the exponent 5 divided by 4 to the exponent 3. Now what we can do here is say, well, really, 4 to the exponent 5 is 4 times 4 times 4 times 4 times 4. And that's all divided by 4 to the exponent 3, which is 4 times 4 times 4. Take a moment and write that down. Jeez. I know, so good. Now, you know what? I had a cousin who drank a lot of juice as a young kid, and didn't like the taste of water as well. Same idea. So now we have this here, and remember, whenever you divide something by itself, it's 1. Now, it's 1, and because everything's multiplying here, you multiply anything by 1, it's like kind of like doing nothing. So a lot of what math people say is that things cancel out. So we have a 4 divided by 4. 4 divided by 4 cancels out, just like that. And how about the next one? Yeah, one more. Okay, now, what are we left with here? 4 times 4? Absolutely. And you say? 4 to the exponent to 4 to the power of 2. Absolutely. Now, if we wanted to go and do this the short way, we don't want to do all these 4s and cancel them out. We don't want to do all that. What is the law? Yeah, what's the law? Yes. Because these exponents have the same base 4, and they're dividing by one another, what we're allowed to do is take the top one and subtract the exponent of the bottom one. So here's the law. If we have x, base x to the exponent a, any number, divided by x to the exponent b, what we can do here is say x to the exponent a minus b. We're just subtracting the exponents there. And we're not shocked by that because when we multiply, we add. When we divide, we subtract the exponent. Just like multiplying and dividing are opposites, adding and subtracting are also opposites. Now, I have to add this in here, and it's not anything you're going to have to worry about, but I have to add it in for me as the teacher, and it's this thing right here. This law, it says, is not true if the base value x is 0. Now think about that. Remember before when we were talking about vertical lines and vertical slopes, we said that the slope is undefined because we would be dividing by 0. And in math, we say that that's against the rules. We can't divide by 0 because that value that you get is undefinable. We can't actually define when we divide by 0. So if this base value here was 0, we're dividing by 0, and that's no good. That's no good at all. Okay. Now again, not for you to worry about, for me, so I can go home and I can look myself in the mirror and say, yes, I've taught this right. Okay, we have 4 to the power 9 divided by 4 to the power 7. What is our shortcut answer, Riley? 4 to the power 2. And how did you get that? Right, took the exponent 9, subtracted from the exponent 7. Now, dividing can look a lot like that with the line. Dividing can also look like this. And if you ever wondered about this division symbol, notice how it kind of just looks like a fraction, right? See that? It's like numerator, line, denominator. That's where that dividing symbol comes from. So we have z to the power of 8 divided by z to the power of 2. Anyone have an answer? Yes? Genius. Z to the power of 6, I agree. Now how about this one? This is where exponent laws come in super handy because you can't just type in negative 6 to the exponent of 50 in your calculator and get a beautiful, wonderful answer. Same with negative 6 to the power of 30. It's not the nicest answer. But with exponent laws, we're actually able to work with these types of large numbers. Riley, what do you got? That's right, negative 6 to the power of 20. Great. Okay. Sorry, did everyone get that? Negative 6 to the power of 20? Now, you're probably, if you were out there, you're falling asleep during the first law, and the second law didn't surprise you at all. That's great. Now, a lot of the times what we like to do is combine the laws. So, what do you mean? Now, what we're going to do is, I would like I have questions that we could go to the board with, but I personally think the questions that I had made earlier to go to the board with are probably a little bit too simple, and I feel like this is going to be more our style. So there's these 4 questions here that we can practice, and then there's 2 more that are like, yeah, like here's what they look like. Right? Right? Yeah. But you know what? You will not be shocked by the answers to these by the end of this lesson. Promise. So we will start. So go ahead and start writing these down, and I'm going to start organizing the cards and maybe turn off this YouTuber here. Pardon me?